Right. Hello. Welcome back to our CCNA series for 2025. So I'm JJ, your lecturer for the entire series. And for today's topic, we're going to have an overview of the difference between IPv6 and IPv4. So we're going to have, so this will be a long discussion. So I'm going to split this into two. But for today, we're just going to focus on the difference between IPv4 and IPv6. And then on our next episode, we're going to know the difference between EUI 64 formatting and how does the IPv6, how we're able to create IPv6. But for now, let's focus on different packet types like for this one and the difference of IPv4 and IPv6. So first, for IPv4, if you remember on our previous topic, on DHCP, whenever we're having problems to, let's say this one is IPv4 and you configure a computer and assign it like a dynamic setup for getting the IP address. So if you've noticed, if we're not able to reach the DHCP server, which what happened last time, we're receiving IP such as 169.254.x.x. So this is the auto configuration for IPv4, and you might have heard this before. So this is called as APIPA, or automatic private IP addressing. So what it means is Windows or your device will create its own IP addressing, which is for this one reserved for that, so that whenever there's like no setup with that network, your two PC, your two computers will still be able to communicate, right? And for IPv6, so we're going to differentiate that right now. So if you're going to see the FF80, and there's like a bunch of octets here, which is, if you've read the definition of IPv6, it's basically having this value and having the MAC address in order for those devices to connect, which is called the link local. So for the link local, it's specific for IPv6 that it will create its own link local for that specific interface, which is not available, or which is not included in IPv4. Why is that? Because in IPv6, one of the main difference between IPv6 and IPv4 is that you can have multiple IPv6 on a single interface, and all of them are working. So you can have a link local IPv6, you can have a global IPv6. Like with IPv4, you only have one IP for that single device. Okay, so we're going to focus on that, so that next time that we're going to have our lab, we're not going to have a discussion between the difference with this one. So if you remember, unicast, in IPv4, unicast is just saying that, okay, I have one packet to send to another device, and that's only like single to single network. So if I'm going to send like 192.168.1.10, we know that we're just sending a packet to that specific device. While in IPv6, yes, you can do that, but we have here different options. Like for example, it already has its global unicast, which is like the public counterpart for IPv4, and it has a unique local for the private counterpart for IPv4, and also the link local, which we mentioned that it will be automatically created using the MAC address of that device, just for two devices to connect to each other. So meaning, like what I've told you, you can have a single interface and all of the IP is already there and all of them are working. So you don't have to convert it you don't have to create a NAT or translation towards it. All the single interface can have all those value at once. Okay, and Anycast, so this is not native for IPv4, but there's like a way to configure it. But I'd like you to think of Anycast as somehow it's a type of packet that almost similar for load balancing. So for load balancing, it's a way for us to control traffic. Let's say you have multiple PC here, and then the IP of it's like a server, like maybe like Facebook, So we all know Facebook. There are multiple sites for Facebook. So let's say this one is 192.168.1.10. Then this one 192.168.1.11. So this is the traditional setup for IPv4. The goal is you can have anyone from the server to connect to from the source. Now, unlike with the setup, if you're going to compare it to IPv6, on IPv6, you can have a specific IP address for them, and whoever comes near to the source, or to whoever send the request, will go to that device itself. So it's kind of, just think of it, it's like it's a native load balancing in IPv6. Okay, and for next, multicast. So multicast, we're using it when we're sending updates for routing protocols. So if you've read some of our previous topics, so we've discussed how multicast work for different routing protocols. It's a way for it to send the routing updates. And for multicast, it's select it. You know which servers, which IP you should send the updates to. So that's the difference between multicast and broadcast. Because a broadcast, it will send it to whoever part of that network, right? So for this one, for IPv4, this is the specific multicast network, the 224.0.0.0, while for IPv6, this is the default multicast. So just always remember that this is more of like for this one, this is just like the same with private IP. If you see that the network started with this one in IPv6, you know it's going to be a private IP. And if it's starting from this one, you know that it's going to be a public IP. This is a matter of understanding, and it's the same with IPv4. Remember that we know it's a private Class C network because it started from 192.168.1.0. We just know by default that this is a Class C network because we're always using this one. And since we're still not adapting fully the IPv6 addressing, it's more of like getting familiar with all of these numbers first. This is the APIPA, like what I've told you last time. So the difference between APIPA for IPv4 is 169.254, while the APIPA for IPv6 starts with FE80. Right? So if we're going to, let's have our packet tracer up. So if going to check IP configuration here, so say I did not create a DHCP server, but I assigned this computer as dynamic. So what will happen is it will get a random number from the range provided, the PIPA. So 169.254.x.x. So for this one, 125.30. And for the next one, you can see here 52.80, right? So what's the goal for that is that we're able to communicate to PC regardless if there's no setup or configuration for the DHCP server. That's why they created that format. 169.254. What's the IP again for this one? 52.80. Okay, so yep, as you can see, we're able to connect these two devices without having or making configuration. So those 169 value, it's an IP address, so it's still going to work regardless if you set up or did not set up. So it's a way for those computers to connect to each other, regardless if there's like a network setup for those computers. And the APIPA for IPv6, so this is it. the FE80. So once you see FE80, it's just like equivalent for the APIPA for 169.254, like this one. This and this is for the IPv6. Okay, so this is very quick because next time we're going to deep dive on what the EUI64 format for IPv6, and I just like to have you guys idea what are the different packet types, and it's very simple to understand. As you can see, unicast, if it's a single um, device that we would like to connect. For any cast, so any from those devices, or any from known devices or IP address, or we can send it to. Again, the example that we've shown for that is that for load balancing setup, for balancing the connection or the connectivity. For multicast, so it's a selected destination, and you know who the devices are that needs to receive that packet. While the broadcast, it's going to be all the network, all devices under that network. And of course, we have private IP, public, and the loopback IP. So it's like the IP itself. We all know this. Like whenever we set up like a server, this is usually what the IP is about. It's basically saying this is the local IP of this device. And for APIPA, we just explained the value that we're getting for both IPv4 and IPv6. Okay, so that's all for today, and see you again next week.